Hi, I am Nicolas Moreau, and today I will be walking you through how you can use the Microsoft Search API in the Microsoft Graph in your own custom application. So a little bit about me. My team works on Microsoft Search API, both the backend that powers the search experience, as well as the API aspect. So from the search experience, we power Outlook, SharePoint, Teams, and more. So the Microsoft Search effort has started about 4 years ago to bring more intelligence in search, to make it more coherent and consistent across the different experience in our product. And now we're at a point where we are starting to make some capabilities available to developers so that you can integrate search within your apps. So today I will be talking about Microsoft Search and the Graph API to give some context and explain what we can see in the experience and what is exposed in the API programmatically. Then I will spend some time walking you through the API shape, how it looks like, and a bunch of demos. And finally, we will look together at an example of an integration in a Microsoft product, Microsoft Dynamics Knowledge Management, and how they leverage the Search API to search content in M365. So Microsoft Search mission. So Microsoft Search, the goal is to connect you to knowledge, expertise across your org and help you be more productive, take action. So one of our goals when we started this effort was to avoid the fragmentation of search experiences. It's true that with Microsoft 365, information can be stored in many different places. Email is one place. Document in email is something very common. Document in OneDrive or SharePoint, and customers don't necessarily know, end users don't necessarily know whether it's OneDrive or SharePoint. And now with the large adoption of Teams, Teams become yet another place where you can share, send information. So that becomes an information silo. So given that blend of information silo, we had to come up with a shared search backend, which can power a cohesive search across all experiences. An additional consideration that has been accelerating this effort is the opportunity provided by all the rich signals you can get from our applications when users use them. For example, when you spend time editing a document, this is a super interesting signal that tells us that this document matters to you and probably to your peers as well. When you participate into a long email thread, this means that this conversation most likely contains meaningful information and that the people in that thread also matters to you. So all this information are collected across many different experiences, consolidated and used in search to provide relevant results. So why did we decide to build a new search API in Graph? So if you're a developer and you want to pull Microsoft 365 data in your app in a search experience, you can already use some existing search endpoint. Search has been there and has been there for a while. For example, email search is something that is available on the Graph Search API today. File search as well has been exposed in SharePoint REST API as well as on some endpoints in Graph. But the problem is that these search endpoints are built and anchored to different backends, and we end up into a very fragmented state today. You have to use one API if you want to call email, another API if you want to call files in SharePoint. The Microsoft Search API is agnostic to the workload. We designed it so that it can scale and add more content types as we will increase our scope. One additional consideration is Graph connectors. With the Graph Connectors platform, you are now able to ingest external content into Microsoft Search and surface this into our search experience. This can be achieved through some pre-built connectors, so SQL Azure, FileShare, you can index this information, or via partners who are building some custom connectors, or even yourself, because there's an API actually to ingest that content. So our ultimate goal is to expose to you what our first-party experience is using so that you can bring this information and you can kind of replicate a similar experience in your own context. For example, if you're a large company and you have built a mobile app, what I would say companion app to access key corporate information, you can expose search within this app so that end users can search across files or on their email using that API. The last point is about intelligence. Existing search endpoints mostly have bare-bone relevance, primarily driven by some frequency. They don't use the strong signal that I've been talking about. Um, email doesn't. Email search doesn't even have relevance. So as we are building these intelligent feature and bringing really rich relevance, we wanted to make this to you available programmatically. So now let me walk you through 3 key search experiences very quickly that you will be able to replicate in your application using the Microsoft Search API. So the first one is Outlook. So Outlook search results have been sorted by dates for almost decades. That was good, but now with the volume of email and the flow of email that have accumulated, people are expecting more. And that may not be good enough to really find what you're looking for. Therefore, we've introduced the notion of top results in Outlook, which leverage the signals that we've been talking about to promote 3 emails you believe are more relevant to you. This capability is exposed in the Search API. Second experience, SharePoint. So searching in SharePoint has been also significantly improved in the modern search experience. The relevance you get in SharePoint for all content or for files is available via the Search API. You will get the same consistent results. And lastly, connectors. As I talked about with the Graph Connectors platform, you can ingest external content and surface this content in custom vertical in modern SharePoint search experience. You can do this today via customization. The same capability, searching the same piece of information in connectors is also accessible using the Search API. So now that we have set the context on why we've exposed this new API, I will quickly talk about the capabilities and the structure of the request and response, and then I will be doing an actual demo of this API call. So first thing, the anatomy of a very simple request. This is the most simple search query you can do today. So one significant difference with many other graph workloads is that mostly on graph today, you do get to fetch content and you do post to update or create content. Here, we take a little bit a different stance and we are actually sending a post to get content. The reason we did that is that search query can be fairly complex, and we believe that passing parameters in get doesn't really scale really well, especially if you want to provide some sophisticated features. And we will see later that there can be some fairly complex search query. So this is why we took the stance to pass all the information in a post. When you make a search query, you need 2 things at a minimum. You first need to provide the entity type. So the entity type is an enumeration that contains what are the actual information you want to get back in your search. So in this particular example, this is going to give you email back. The second piece of information you need to provide is the query string. The query string is the basic string of what are the type of terms you want to search. So that is for the request. For the response is a little bit more complicated. First, you get search terms. So search terms is echoing the actual end user query. It can be more than that. So for example, if some SharePoint query rules have been applied, then the search term will contain more than that. This is also where in future we're going to augment this section as well. The hit containers, today given one query, we only return a single hit container. So it's literally the container of the results. why we've done this is we've designed this to be extensible in the future and potentially given one query to return multiple blocks. One example is if you search for email and documents. Today we don't merge them. So today, if you're asking for that, we send you a bad request. This is an invalid combination. In the future, we could say that some types are compatible, but we want to return two different containers, one with email, one block with email, and one block with document. You get total, which is the total number of match in the index, as well as more results available, which is a Boolean that indicates that if all the results fit on the page, or if there are more results. And to get more results, you can do paging and ask for more. And we'll look at paging a little bit later. Hits. This is the actual list of search results. So every search result is a hit. A search result contains three properties. The ID. This is the ID you can use to actually do a lookup. For example, this would be the ID of the drive item, the ID of the file. And you can use this ID if you want to make a lookup to fetch the file or fetch the representation of the file in the graph. The score is the actual rank of the search result. It's an integer that represents the position in the set. The summary is a fragment of text before and after the search term, and it can be used in the UX to help users understand if the document is relevant to you. And then finally, source is a field that actually contains underneath the actual graph entity, the graph entity returned. So let me talk about that. The graph entity that we get in the example, I think here we're getting a drive item, you're getting a file. We have made an effort to provide the most comprehensive representation of the entity in the graph that we have, because in the search index, we don't have everything. We are able to search files. We are able to get certain properties for file. Well, for example, you are able to get the file name, the description, the path. The actual content of the file is not stored in the index, or some other information are not stored in the index. So what we've done is for each and every type that we let you search upon, we've done a mapping of what is available in the search index with the representation in graph. So it is not a fully hydrated graph representation, but it's the most you can get from search. And if there is a property that is not available in search that you want, let me take an example: contributors. Who are the different contributors in this document? Then what you have to do is to use the ID to make a details call to get the resource, to get the drive item, and on the drive item to ask the properties you want that are not returned here. So now let me talk about the API capabilities. So this endpoint in the Microsoft Graph has been there since about 2019. This is the endpoint that is available in the graph. So the good thing of being in the graph is that it follows all the same principle around authorization, authentication. So all the goodness that you have around graph on how to secure this access, how to grant permission, everything is really consistent, and the search doesn't behave differently. The query is scoped to entities. As we've seen in the previous example, when you make a query, you define which are the entities you need. So we support message, email, calendar events, and we SharePoint drive items, which are the representation of file in SharePoint and OneDrive, as well as external items, which is the representation of an item ingested via the connectors platform. The results in the search result are graph entities, as we've seen in the previous example. We've been trying to hydrate we don't return just a bunch of property. No, we return something that looks like a graph entity. From a query perspective, we support all the KQL of the underlying workload. So KQL stands for keyword query language, where you can say from : an address email, or file type : to filter file search for specific file type. So we support all the complex KQL of the underlying workload. These are supported, and you can use them in search. And by the way, it is very often the way you can really customize and tailor your search result using this KQL query. This is the way to filter results. So this is what we had since last year. And now I'm just showing what is coming. And this is going to come in about October 2020, still in beta, some more capabilities. So the first thing that is coming is we are putting more entities on OneDrive and SharePoint. We used to have drive items, so files. So now we are putting a list item. I will talk a little bit about it later. List item, lists, sites, and drive. So these are new types that you can request, as well as type that you will get in the response. The second addition is what we call select properties. It's the way to scope, given a request and an entity. I'm requesting for files, but if I only need 3 properties for file, I just need the ID, the title, and the path. I don't need the full representation that we return by default. You are able to filter and narrow down to these particular select properties. This is a way to reduce the payload over the wire. We've added the ability to sort results. So by default, and this is documented, by default, each type has a default sort order. So for example, the default sort is by date. For file, the default sort is by relevance. But you now have the ability to customize and to say, for example, I want to sort files by author, or I want to sort file by size. This is now something you can do. And the last addition we've added is the ability to refine results with aggregation. This is something that has been, our community has been very vocal about that this is something that is needed. When you build a search experience, you want to be able to expose filters to end users so that given a query, they are able to see, oh, there are as many Word documents, as many Excel documents, or the most represented author in this query is whoever. So the ability to return aggregation on top of result is something that we have added. It's also popularly known as refiners. So this is something we've added. So now I want to show you a little bit more in details different ways to interact and query the data. So for my demo, I could have used actually Graph Explorer, which is an available tool that enables you to play and interact and query data in the Microsoft Graph. In Graph Explorer, on the left-hand side, there's some sample queries, and there are some search queries that you can use to actually play with the data and execute the query. I will not be using Graph Explorer. I will be using Postman, which I think is a little bit more sophisticated and more flexible tool. Postman, there is Jeremy Take has done a great job putting together a Postman collection, which actually captures a ton of samples on how to interact with data, and search is participating into that. So I strongly recommend, if you are playing with Microsoft Graph, to use this Postman collection. It is really awesome, and it's being updated regularly. So the Postman collection contains the actual sample that I'm going to show today, and you can use it. So before using Postman, there's a couple things you need to do. And the same way as you're building your app, you will need to go on your tenant to the Azure portal and actually register your app. This is a step that is required for Postman. You don't need this for Graph Explorer. This is already done for you. So it's needed if you want to interact with Postman, and of course, if you want to use an app, integrate in your custom app. So what you will need to do is to actually register an app. This will provide you an app ID. That's one piece of information that is needed. The second piece is you will need to create a secret that will be embedded into your app. And the third thing you will need to do here is to actually register permission to tell what type of information the application is allowed to access. So for search, these are the type of permissions we need. We need to be able to access calendar information, email, files, and sites and external items, depending on what you want to access. If you just want to access file, you can just grant this permission. So here the permission the consent has already been given, but if the consent is not previously given, then the end user will get a prompt, the consent prompt, to ask him if he allows the application to access this data. So this is a little bit of configuration you have to do ahead of time on your tenant that will give you 3 information that you then can use in Postman. So in Postman here, I have registered an environment where I have pre-configured these 3 the application. So now when I go, the first thing I need to do in order to be able to execute a search call is to get an access token. And here, when I send the query to get the access token, actually this gives me a token back with the scopes that I requested. And this token, I am going to be able to use it for the subsequent call for the rest of my demo. One important thing to notice about the token is that the access token, I will not show it here, but actually once we execute this request, the access token is being stored in a variable, and then it's being passed on the subsequent request in the authorization header. So this is hidden for you, and this is done in the Postman collection. So for all the search example I'm going to go through, they are located in the Microsoft Graph collection in the on behalf of a user folder under search. So we'll start with the very simple query that actually looks for messages, so email, based on the query string contoso. So this will retrieve all the email that contain contoso in their body, title, anywhere. So the default page for search is 25 results. So here in that case, you will get 25 results. The second query we're going to look at is talking about paging. So this is how you express paging. The from is the offset where you start from, and the size is how many results you want. And you can go like, I go from size 15 to page 15. So you will still get 15 results, but then the index is 15 item later. Now let's look at search message top results. So as I've shown a little bit before, now Outlook has this capability where we are showing top results in the top 3 results in the search results. So when you enable top result, this is what's happening to you. You get 25 results, but the item 1, 2, 3 are actually some results who are indexed as sorted by relevance. The top 3 results are sorted by relevance, and the rest is sorted by date. So this is a way where you could kind of replicate a similar experience of what are the most relevant emails satisfying a query. Note that the current number of 3 items is currently hard-coded. You cannot currently modify and expand that list. You cannot get 5 items, 5 relevant items if you wanted to. The next one is searching for calendar events. So here, calendar event is an entry in the calendar. So here I have a Contoso product plan review, which is an event in the calendar when you have basic information around the date and time. So this is typically used in Outlook as well, in Outlook Mobile, where now calendar entries are being represented differently from search results. So we've seen here mostly elements related to Outlook and Exchange. So now we're going to move on to files in SharePoint and OneDrive. So this is a query that will return any file regardless where it is located, so OneDrive for Business or SharePoint. So this query will get files stored either in OneDrive and SharePoint and cast them as drive item types. So this is how a drive items coming from search look like. It gets some basic property, created date, name, the URL of the document. It got an ID that you could use to make a drive item details call. So calling drive item by ID
using the graph files API is something you can do with that. It also contains the name, the site ID of the container of the site in which this particular file is contained. Here, just to illustrate use of KQL, you can narrow down, you can use a lot sort of filtering in search to narrow down here, for example, file only that are docx. You can have some custom filters related to path, author, and so whatnot. So this is something that is very flexible and that you can very easily use to filter search results. So now we're going to see lists. So let me take an example on how this is working in SharePoint. So today on my test tenant in SharePoint, I have a communication site, and I have created an issue crash tracker list that was a built-in list that I created. So yet now I have a new container that can contain a list of issues. So with the Graph API, when I query list here, and specifically with the query issue, because the description is issue tracker, when I execute this query, I am getting the list back. So for the moment, we're getting the ID of the list, but we're working to add more properties so that the name and description are more relevant. So once you have the list, you would be able to enumerate the items. Now, list item. So the concept of list item is an item in the list. This is a super generic concept in SharePoint, and actually files are list items. Any item is a list item. So when you query for all the list items, you get a lot of things. But what is mostly interesting in this particular context is to actually query the list item. What I would want to get is to get this particular list item. So I have my list issue tracker. I have one issue in the list. This is the item, and this is what I would want to search for. And when I execute the query with the question contoso issue, then this is going to pick up the one item that is available on my tenant, and that satisfies this query string. But the thing is, on these items, typically on my issue list, there are some properties that I may want to get back. So typically, what is the name of the, because this is a custom column. Issue is the name of the column. It's a custom column. So what I want to get is what is the content of this particular property. So this is where property selections becomes really interesting. You are able to scope specific field and to reduce the fields you want back, and to say which specific fields you want back from a particular query. So here, what I'm going to do, I'm going to execute the exact same query for list item with the same query string. And what I will get back, the big difference here is this is the same, but given I ask for some property that are not in the schema, I am getting a property bag under fields that contains the class and the title, which are the items that have been requested here. Note that I need all these property needs to be present in the search index. Otherwise, if I'm asking, for example, for an additional property that is not present in the index, foo, then this property will, the fields is not going to be populated with this value. Note that the concept of stored field is something also that you can apply to files. So for example, here in files, I can say, I want, I have a file query, but the only thing I care about is the ID and the web URL of the item. I don't care about the rest of it. So this is, I switch and now I'm back on files. And when I execute this query, I will get kind of a trimmed down version of the drive item with only this property. So this ability to scope properties has can satisfy two scenarios. The first one is when you want to trim down the response over the wire, just to get the property you want back. And the second one is to expand in the context of a list item to expand to get more data that you will not get out of the box. Now, going to sites, entity type sites, this will give me all the sites that are available on the tenant. Again, we're working to add a little bit more information on the site, typically site name, description. But this will enable you to iterate and to enumerate what are all the sites available. Drive is very similar to sites. The concept of a drive is something that is, the concept of a drive is actual document library. It's an encapsulation of the document library. So this will return the document library available on your tenant. Okay, so now I have covered here Exchange queries. I have covered files queries for OneDrive in SharePoint. And now this specific example is very interesting, and it is related to the Graph Connector platform. So I talked about a little bit earlier that the Graph Connectors platform enables you to ingest external content into the search index. So here I'm going to show in my tenant admin. So I moved on the tenant admin. I'm a tenant admin, and I'm going to go in settings, Microsoft Search, and I'm going to show which connectors have been created on that tenant. So you can see in the search admin that I have created two connectors. I created SQL Azure connector that are actually ingesting the AdventureWork DB. They both ingest the AdventureWork DB. And you can see that a connector has a connection ID. This is the connection ID, Azure SQL connector do, and as well they have a schema. And if you go in the edition, you can see the schema. So when you go when you query connectors content, you need to specify external type as external item. This is the type that encapsulate all connectors content. So that's the first thing you need to specify. And the second thing that you need to specify that you don't do for any other types like message, files, list item, and so on, you need to specify the content source. The content source is the name of the connection to the connector. And it is prefixed with external/connections. And this is the name, the connection ID that is present here, Azure SQL connector. This the connection ID here. So when I do that, I can execute a query. There's something else that I need as well to add is I need to specify the fields I want back. So in the schema, when you configure the connectors, you can create the schema. I know that there are these three fields. And when I execute the query, this is returning me. So the query is A star LU star. So I get two names. So I ingested the customers. So these are people that are ingested through the Azure SQL connector. So I get April Luo and Emil Liu. Now, if I have multiple connections, I can very well, in the content source, specify multiple connections. So they are separated by comma. So it's a collection of content source. So here, when I execute this query, given the content ingested is the same, here we have two results. If we execute this query, we're going to have four results. Note that the ordering of the results here is a little bit skewed because the content is the same, but the content, the search results are ordered by relevance, and we are building relevance across the different content source. So you will get a sorted list across the multiple connection. The algorithm used is literally using term frequency and how far the query is from the actual search term. So it's something fairly basic. And there is work to actually define in the schema which are the fields that are most important. This is also defined, referred as semantic labeling. And if you want to know more about that, so there are some talks in the Graph Connectors platform documentation, you should be able to see that. So that's all about for connectors. And now we're going to complete with this demo with two of the last features we've added. The first one is sort. So in sort, to express sort in a query, there is a specific property you need to pass in which you define the property you want to sort on and the sort order you want to apply. By default, as I said, based on the entity type, there are some default sort applied, but you can override this. Note that today sorting only applies to SharePoint items. Sorting does not yet apply to connectors or even Exchange items. So here in the example, I want to sort the items on the Contoso query based on the size of the file. So when I execute this query, what happens, get 16 results, and you can see that this file is 31K, and then it's increasing because I have specified is descending equals false, which is the default, and it's increasing. And if you change this to true, then you will get at the beginning the large files and then the smaller files. So note that sorting works on numeric properties as well as on string properties. The very important thing to note is that in order to be able to sort on a property, the property should be sortable in the search schema. This is particularly valid for SharePoint search schema. Now let's talk about refiners. Refiners or aggregations. There's different semantics on the industry for that. So what is a refiner? So I think the best way to explain this is to show an example. So in SharePoint, for example, when you execute a search query, you get search results. But if you want to filter, here this list here is not a static list of filters. Here, Word, Excel, PowerPoint show up because there are Word, Excel, PowerPoint documents in the result set. So aggregation is a way to give you an idea on how the items are represented in the search index. And what you do is you specify a property. For example, I want the aggregation on the file type. And if you express this in the request, you will get on top of the search results, in addition to the search result, you will get a second block, which will tell you, okay, based on your query, here are X amount of Excel file, X amount of Word file, X amount of whatever type is available in the index. So this is to illustrate what the refiner / aggregation feature is. So the way to express this in the request, this is I am on top of the query. You pass one or many aggregations. So here in this example, I would need to pass two aggregation because I want the aggregation based on file type, and I want the aggregation based on the last modified date. So here we will be focusing on string aggregation. What it means? It means that these are aggregation where we are going to get in the results the list of the discrete values of the file type string. So here, this aggregation is expressing that I want to return the aggregation based on the file type properties. I want 20 20 values. So here we only get 3, but there could be a lot. So this is kind of the max, the size that you can get. I think there is a hard limit in that. And then you decide to sort the bucket. So this will give you a bucket. So this is a bucket. You will have a Word document bucket, a PowerPoint document bucket, and an Excel document bucket. And then you specify how you want the buckets to be sorted. So sort by count descending true means that you will get the most represented buckets. So how many buckets have more document and will be descending. There's another way where you can sort as well the bucket is instead of sorting by count is to sort as string. So imagine you get that for content class is a good example. Content class would give you what is the ordered list of content class you have in the set, and they will be sorted by alphabetical. So when I execute this query, what will I get? So let me go with an executing Contoso. So I will get files. I will get files from the index. This is what I get. I get, remove this. I get a drive item here. So I will get all the files. I get here 7 files. All the files are available on the page. On top of the file, I'm going to get two aggregation. Why? Because I requested two aggregation, the file type and the content class. And if we look at the file type aggregation, what do we get? So we get the list of buckets. The first bucket says that the key is docx. So the key of the bucket is called docx. So in this example, docx. There are 6 documents, and here is a token. We'll come to that later. And there is one PPTX, and there is one XLSX. So, and if we look at the content class aggregation, we can see that there is only a single content class aggregation because all the items are of type document library. Okay, so now we're going to look at the second type of aggregation. So we've seen strings. So the example is file type. And then we take a look at the different type of aggregation, which is numeric aggregation. So here, same query, contoso, but this time I'm going to request and we're going to ask to get the aggregation based on size. The problem with size is that there are going to be a lot of different sizes. Unless for file types, you get only a few file types. Even in a large tenant, you get a finite number of file types. Here, for size, you don't have that. So the idea here is as you pass in the aggregation, you specify ranges. And the ranges will define, okay, this means that this you express in the request that you want to get 3 buckets, one below 100, from 100 to 1000, and above 1000. And when you execute this request, again, you get the search results, and you get the aggregation, and you will get 8 documents in the last aggregation because most of the documents are larger than 1000. So we've seen refining aggregation by strings, aggregation is numeric, but so we've only done one part of the puzzle. We have been able to display this thing or to display that block. Now, what about how do I filter to actually make another query and say, oh, this is the bucket I want. Give me only the document in this or that bucket. So the way you do that is this is where the aggregation filter token is being used. This is something that you need to pass back. So when I click on Word, for example, if I go in the refiner string, if I go on Word, what I will need to pass is this aggregation refiner token. I don't need to know the value. I know I need to pass this back in the query. And how I do that to apply in the request, on top of the request, I specify the aggregation filters and I specify the property that I want, and I concatenate the property with the filters I need. And if I send this query, then I will get only the hits that I need. Note on how the aggregation filter should be passed. You need to concatenate the property name, colon, and the encoded token that you got back. All these examples are available on the Postman Graph collection, available on GitHub, and you will be able to use them to try it out on your test tenant. Now I will show one example of an integration that is using the Search API. So I will show how Microsoft Dynamics is planning to solve one specific user problem using the Search API in Graph. So the problem they are trying to solve is to allow knowledge workers to search across content in context of their work. In most companies, the knowledge is fragmented across the organization and stored in different data silos. So they wanted to provide a way to search external content within the Dynamics user experience. So in order to do this, they prototyped a solution using federation. So typically the scenario is a service supervisor would configure external sources that you want to expose in the end user experience. In the administration, it is possible to define many different search providers. So the type of search providers that are available are the search provider that is searching across the Dynamics information, but they added 2 search providers. One search provider is giving the ability to search on SharePoint. And the second one is giving the ability to search in connectors. So here in this example, we have pre-configured providers. One is searching on SharePoint, and the two other ones are searching on connectors. And just to show you how this is really easy to configure, here on the Microsoft Search connector, the only thing you need to provide is the name of the connection ID. And the connection ID is something that you can find in the tenant admin, in the connectors UX. You can pick the tenant the connection ID that is attached to your connection. So now that the search providers are configured, we can now go on the customer representative user experience. So this customer representative has different cases. And in their UX, they expose the ability to search content externally. So here, for example, I can search for bookings. And I can see here the different search provider exposed, and I can find some content in SharePoint, for example. And this content now can be linked to this particular case. And you can also search some content in the configured connectors, who here in that case do not find any match. So I think this is a very good example that shows how within an existing application, you can augment the capabilities using Microsoft Search to search either content on your tenant or external content using the Microsoft Graph connectors. So I hope I've been giving you a good overview of what you can do today with the Search API. We're on a journey. This is the beginning. We are adding more things. More content type are coming, more capabilities are coming. But if you want to learn more, I invite you to look at the documentation. The link is posted here. Look at the Postman collection. Again, there's a link here. I think it's a great way to learn and to try. You can watch and replay some Microsoft Search related videos on YouTube. And finally, please give us feedback. The two ways to give us feedback is on GitHub in the documentation. When you go on docs.microsoft.com, there's a really great feature where you can comment and ask questions on the given page, or in user voice if you want us to provide something new, you have some ideas, or you want to vote on something that you think are needed. Please go in there. Thank you very much for your attention.